So in this question, I've got a parametric curve C, which is drawn here in a sketch. And I've got this point here, which is 7/2 for x. And I want to calculate this area here, going down here, all of this, and also meeting at this point. So in between here, I want the area under that curve. Now, it's a parametric curve. X is defined as t/2 plus 2. And y is e to the power of t minus 1. So x here is 7/2, and I don't know what this point is here. So to find this, I've got a value of y equals 0, because that's what that is on the x-axis. So y equals 0, let's do that here. Y equals 0, and 0 equals e to the t minus 1. Okay, now if we can solve for t, that would be a start. So e to the t equals 1, if I bring this over. So e to the t equals 1. Therefore, that means t must equal 0. Okay, if t equals 0, I can find my x coordinate by plugging t into here. So x equals 0/2 plus 2. So that obviously is equal to 2. So this point here is x equals 2. Now, to find the area under a parametric curve, my formula for my integral is the integral of y dx. And I've got x equals 2 as my first point. And for my upper boundary, I've got my x equals 7/2. Okay, now my y is defined as a y of a variable t. So y is e to the t minus 1. Now my dx, what I can do is here, let's take the derivative of x. So dx with respect to t, because x is a variable with the variable t, take the derivative of that and I get 1/2. And then what I can do is I can bring everything into terms of t by getting dx on its own and changing everything in terms of t. So therefore dx equals 1/2 dt. So that takes care of that. Y is already defined in terms of t. So let's go for that. So y, e to the t minus 1, close brackets, dx, that's 1/2 dt. So times 1/2 dt. And now my parameters of integration, I've got x equals 2. Now what is t when x equals 2? So let's plug that into there. So 2 equals t/2 plus 2. Okay, let's solve for that. t/2 plus 2, what does t equal? That equals 0, so t is 0. So we know that. So we kind of got that there, we just kind of went backwards on that. Now what about when 7/2? So 7/2 equals t/2 plus 2. Subtract 2 from both sides. So I get 3/2 equals t/2. So therefore we can see that t is clearly 3. So then that's our setup in terms of t for our integration. Okay, let's bring this half out to the front. Makes our integral that much easier to work with. 0 to 3. Then I've got e to the t minus 1 dt. Now I'm going to split this into two integrals. So that's 1/2. And then I've got the integral 0 to 3 e to the t dt. And then minus the integral of 1 from 0 to 3. So the integral from 0 to 3 of 1 dt. Okay, now this is a nice straightforward integral. Integral of e to the t. Let's just keep this stuff separate. Integral of e to the t, that's still e to the t. So I've got, let's put my 1/2 there. Now I've got e to the t. Now my parameters of integration 0 to 3, I'm going to put that at the end. So that's that. And then the integral of 1 with respect to t is just t. And there's a minus sign here, so I'll do minus t. And that's from 0 to 3. Okay, let's do our calculation. So now I've got 1/2. Plug in a 3 where I see t, so that's e cubed. and minus t, so that's minus 3. So that's my upper boundary calculated. Subtract my lower boundary, e to the 0, and then t is 0, so subtract 0. Pretty trivial, but I'm going to put it in there. So now I can simplify things. So I've got e to the 3 minus 3 minus e to the 0. E to the 0, this is just 1. So now I've got e to the 3 minus 4 multiplied by a half. So I've got e to the 3 minus 4 divided by 2. And that would be the area under this curve. Okay.